Welcome to the UN Climate Change Global Innovation Hub. Now it's midday here in Dubai. I welcome everybody here and also everybody who is following us via YouTube Live. We are about to start session number 3 of the day. This session is called, and I think it's a very interesting session, this session is called Mood Beams. How digitalization of crop stress accelerates resilience and sustainability of global agriculture. So who is going to guide us, who is going to facilitate this session is Mr. Guy Hudson from Lom Bio. He's the CFO of the company. So Guy, floor is yours.
Thank you very much. I'm not sure my CFO would be very happy with that, so, but I'm the CEO of the company. So nice to meet you all. Look, we're going to have a relatively intimate session here, so good to be able to start this off. We also have 2 of our colleagues joining us from the US who've joined us in the middle of the night, so thank you very much for doing so. I don't know, are we going to be able to see our colleagues on Zoom? Yeah, okay. There we go. Hello, Ben. Can you hear us?
Hello, I can. Can you hear me?
So we only have Ben.
All right. Well, look, thank you, and thank you very much to the United Nations and the Global Innovation Hub for hosting this session. It is one that is a big part of the agenda here at COP. We're seeing an increasing level of importance being put on the role of agriculture in addressing climate change. And for us, that is something that is desperately needed and very welcomed on the agenda. As many of you know, the UN, you will have heard this probably many times over the last couple of days, but the UN predicts that a global population will reach nearly 9.7 billion people by 2050. And the FAO estimates that we need a 60% increase in food production to feed that many people. Innovation over the last kind of 40 years or so has led to catch up with myself. Innovation has led to a doubling of cereal production over the last 40 years. But as we know, this has come with some serious environmental impacts. According to the IPCC, agriculture contributes between 16 and 27% of global emissions. This is particularly nitrous oxide, which is 300 times more potent than carbon dioxide. In spite of our massive production gains, the next evolution of agriculture really needs to address the sustainability challenges that we face. Farmers currently rely on widespread use of key chemistries to mitigate the risks and protect yields. However, studies have shown that farmers lose as much as 40% of their yields, that's about $222 billion worldwide, to pathogens in spite of over-application that sees as much as 30% of pesticides wasted. In face of such challenges, farmers face the increasingly difficult burden of producing a great deal more food in a changing climate, while reducing agricultural impact on the environment. Now, we've got some brilliant panelists here who are working on technologies at many different levels to be able to support and evolve as we innovate to be able to satisfy the sustainability requirements we have in agriculture. With recent advances in microbial science, satellite-based Earth observation, artificial intelligence, autonomous systems, computing power, and plant engineering, we can continue to drive productivity gains in agriculture while dramatically reducing the environmental impact. From microbial fungi that work with plants to take CO2 from the air and store it in the soil for hundreds of years, to a genetically engineered soybean plant that leverages data traits, specific genes that digitize plant stress by enabling crops to emit an optical signal visible from space, we're on the cusp of a sustainable agricultural revolution. Now, this panel aligns with the Sustainable Development Goals around resiliency and ending hunger and achieving food security. I'm really excited to introduce the panelists because we have a range here from the corporate innovation and at-scale innovation with John Deere through to startup innovation with Shelly Aronov of Innerplant, through to the investment side of things, and Zach at GIC. the Singaporean Sovereign Wealth Fund. And I think
we lost the farmer.
Think we might have lost Brett, who is.
But you should introduce yourself
right,
too.
And my name is Guy Hudson. I'm the CEO and co-founder of Loam Bio. We're a biological inputs company that develop microbial seed treatments to increase soil carbon and stabilize that carbon for the long term. So, Ben, maybe on the phone, I'll pass over to you to start, and you can provide a little context around Blue River and the John Deere story.
Sure. Is my audio coming through?
Yep.
Great. Well, thanks for having me. It's a pleasure to be here. I started my journey in agriculture as was the second employee at Blue River Technology, which was a small startup in Silicon Valley that had big ideas to take advanced technology and help farmers manage every plant. Now, actually, from the beginning, sustainability was part of that journey. In fact, the name of the company, Blue River Technology, was because the whole point of the company was to reduce inputs and runoff that farmers used, such that our rivers could be blue and not some other color or have excess runoff from farmers. And had a great journey there. We developed a technology called See and Spray, which can use cameras, computers, and artificial intelligence to identify every plant in the field and only apply pesticides where they're needed, for example, just on the weed. That company was purchased by John Deere, which has almost 200 years of innovation in agriculture. It's just been amazing for me to be a small part of that story, from the first innovation with a new type of steel for a self-scouring plow, or 100 years ago, the internal combustion engine into a tractor. And now, as we look into the future, continuing that story with Blue River, excited about the possibility that edge compute and software, artificial intelligence, better sensors, combined into robotics can help farmers be more profitable and more sustainable. We see a future in which those two things happen together and aren't necessarily in conflict. So very happy to be here today.
Thank you, Ben. And maybe, Shelley, you can tell us a little bit about your work at Innoplant.
Hi, thank you. So I'm Shelley Aronov. I'm the founder and CEO of Innoplant, and we make plants that communicate. Really the mood beans, I suppose, because they're soybeans. We do this by tapping into the plant's natural reactions to stress. So all plants are really smart. They know how to protect themselves from their environment. Because they're immobile, they've learned over evolution of millions of years how to activate genes when they're attacked. So for example, if a plant is eaten by insects, it's going to produce a compound in its leaves that makes the plant taste bad and repel the insects. If it doesn't have enough nitrogen, then it mobilizes its roots into the soil to extract nitrogen. And all these reactions are very early and they're very specific, but the problem is they're all happening on the molecular level, so we can't see them anyway today. So what we do is we teach the plant, in a sense, by adding a line of code. As you're reacting to your environment, start producing a new protein, and that protein fluoresces and creates an optical signal that we can then capture all the way from satellites and to the John Deere equipment with our friends at Blue River. And the idea is to enable the future of agriculture where we don't farm around plants, but we farm with them and we farm with nature. By understanding plants and really what they need, we can then only give them the products that they need when they need it, and be able to create higher yields, but also reduce the inputs in our system.
Awesome. Thank you, Shelley. And thank you for arranging this panel. Zach, you're coming at it from the investment side. Maybe for those who don't know, you can tell them a little bit about GIC.
Yeah, wonderful. My name is Zach Mitrich. My investing career has spanned a variety of different dimensions, from early-stage private companies to large-scale publicly traded businesses. I've participated almost in every industry and across the capital structure. I work for a firm called GIC. It's a large global asset manager. It's been around for over 40 years. We've got offices in 11 major cities around the world, and we invest in nearly every asset class. My last 5 years I've spent primarily on developed public market equities, but I've done select growth equity investments across a number of areas, most broadly defined, different hard science technologies that we think will make the world a better place. And so we really believe that capital has an important role to play in fostering and supporting innovation alongside, business acumen, industry expertise, and network that, every investor brings a mix of those attributes to the table when they engage with their, portfolio companies and prospective investments.
Awesome. And as we start to think about how we get these technologies out through into and benefiting farmers and benefiting the world, how do you think about, maybe Shelley, I'll start with you. How do you think about the path to market for some of the technologies like yours?
Yeah, thank you. We actually have a very strong opinion about the best channel to sell to farmers, and the reality is that agriculture is heavily consolidated, and farmers are used to buying from a very small supplier base, which they trust. And the idea is not so much can we replace the companies that are making equipment or delivering different crop protection products and fertilizers and seeds, but instead can we enable those companies to offer better technologies to farmers in a way that's fully integrated into what farmers use. So the question always for us is, what's going to enable farmers to adopt technology in the fastest way? And the answer is something that's really, really easy, is a no-brainer. If you can just essentially buy a product that has a better technology inside and then almost kind of activate it by planting it, and everything just works well because it was designed to work together, that takes away a lot of the hurdles that we hear from farmers, which usually are around, well, I have to do more work, I have to figure something out, I have to prepare something, I have to document something, or I have to buy something new and I don't have the people. Just to give you an idea, if you're managing, 20,000 acres of land, you probably have 5 people working full time. There's literally no one out there that could do something else, even if you wanted to, with all, the good intentions.
Yeah. And Ben, in your case, John Deere has been scaling agricultural technologies for over 100 years now. What, from the kind of John Deere perspective, what does it take to move a new technology or technologies onto the farm at scale?
Yeah, I think two things that initially come to mind. One is that farmers don't have time to wait for a piece of technology or tool to work. It just has to work every day in every field, every time they want to take it out and get something done. And I think that that's something that we focus a lot on, because as many of these emerging technologies, it can be not easy, but certainly the first step is to get it to work once in one very narrow set of situations. And I think that with artificial intelligence in particular, that part is easy. But to have it work for every farmer on every field, either in the U.S. or around the world, who's doing agriculture with different crops and different cropping systems and everything else, takes a lot of effort to make sure that not only the technology works there, but is reliable and is able to be supported, such that a farmer can focus on getting the job done that they wanted to get done, and not on figuring out how the technology is going to help them. I would say that the second thing that comes to mind is making sure, again, with a global customer base, people doing agriculture everywhere with, different crops or different weather patterns or different systems, either making a product that's generally applicable to those situations or very tailored to the local conditions. And I think this is really just getting to know the customer and really understanding what their objective is and what they're trying to get done. And, I think, again, the success for me in a lot of these products is, to a certain extent, they fade into the background. A farmer doesn't even really think about them. They just become to, rely on them. They go out to their piece of equipment, they turn it on, and they go to do the job.
And Zach, maybe for yourself, like from a capital investing perspective, what are the biggest challenges you see to accelerating these technologies?
Yeah, absolutely. So I think the challenges that ag faces is not all that different than what other physical businesses experience. And so there's kind of 3 frameworks I look at along those lines. The first being is, whatever your new idea, your new insight, your new technology is how much value does that create? It needs to be incredibly efficient and create a tremendous amount of value, because that value will really be partitioned between, 2 end sources. One, that value will be passed along to the customer. The more value you can deliver for them, the more likely they will adopt, and the more quickly they will adopt that product, and that benefit will be shared across the industry. of that total value pie that you create, whatever's not passed to the customer is retained by the business, and after costs is your profits. And so those profits can be reinvested in further scaling, further commercialization, more innovation, and more sustainability. And so there's always this natural tension between those two pillars, and both pillars are really necessary for the good of that product to really penetrate the full market. And so, one of those pillars is obviously incenting adoption, and the other one is supporting and fostering that innovation. And so you really need, a new idea or new insight that creates a tremendous amount of value to support both legs of that, two-legged stool, so to say. The second framework is one of, just the reality of selling into a physical and existing value chain. If you're a new sustainable product and you want to enter into an industry, you're going to interact in that value chain in probably one of three ways. One, not every element of that value chain might necessarily be aligned with you, which means you got to either learn to work with them or work around them, but it is a reality that you need to understand from the onset to build your playbook around. Even the parts of the value chain that you're well aligned with, the people that you might interact with that represent those pieces of the value chain might not actually have an incentive function that is well suited to change. And so identifying that early and mitigating it is incredibly important. And lastly, even when you're aligned with a portion of the value chain and the people have the right incentive functions as decision makers, their risk appetite and the timeline that they want to kind of adopt that change may not be always aligned with that of an ambitious, sustainability startup. And so all three of those provide, friction that needs to be well managed, that unfortunately elongates adoption timelines. And that matters not only for how quickly does the sustainability benefit penetrate the industry, but is obviously incredibly important to the sustainability of that business model and the investment case behind it. And the last framework is one of what percentage of the market is available at what price point. In almost every industry you look at, any product, even ones that we deem commodities, depending on the industry, the customer, the use case, they can actually transact at a variety of different price points. And so it's not uncommon for a new business to purposely, before their cost structure is optimized and scaled, to go sell into those higher value areas of that market. However, if you really want to penetrate the full volume opportunity of that market, you need a proactive plan to drop your cost structure so that you can still be profitable across all those different price points. That's required for you to really penetrate the full opportunity. And so for egg broadly, whether you're talking the large row crops or the specialty produce, the other sub-niches, you get a different mix of those different frameworks in those different areas, but those are some of the tools that we use to evaluate it.
But so the problem, though, is that it doesn't necessarily translate. Like, if you go from high-value crops to commodity crops, that's like a completely different business that has nothing to do with each other except that you're growing food. So starting in one doesn't necessarily drive you to the other, unless your Blue River actually, they did do that, but but it's very different.
Yeah, I mean, each one of the different parts of egg all have different attributes, different industry structures, different way that their businesses function, those industries function. And so how you apply those frameworks and whether or not those frameworks are perfectly applicable will be slightly different in every use case.
And I think to the point that you made, Shelley, our ability to be able to recognize the value of the relationships that have been built up between existing agricultural companies and their customer base is crucial to how we can scale these technologies. I mean, from your perspective, Ben, there we go. Ben John Deere, there we go, we'll get there in the end. How does John Deere see the farm and farming evolve over the next 5, 10, and 15 years? And how do you see these technologies really being embedded on farm?
Yeah, I think it's one of those hard questions to really fully predict the future. I think one of my favorite quotes is that we probably overestimate the change we'll see in 5 years and underestimate what we'll see in 10. And I think, that anecdotally speaks true with me. 10 years ago, I spent the vast majority of my time trying to convince people that See and Spray could work, that we could take a camera and a computer and put it onto a piece of agricultural equipment, make it survive every day, and then in less than a blink of an eye from when it takes a picture, actually have pesticide or an herbicide actually fall directly on a weed and not on the crop next to it. That sounded like science fiction to people 10 years ago. And now it doesn't. Now it's just people have come to expect it and are asking how it's going to get better. And so I think, just like when John Deere started with tractors, it was just one tractor model and it was used on every farm for every job, for everything that would happen. We just have to take that first step and similarly learn, how do we take artificial intelligence and robotics out onto the farm, not in a science fiction way, but just in a way that works. And it's all about being smart about our data collection and our ruggedization of electronics and making sure it's affordable, back to the point of financial return for the customers. And so, really, John Deere, we at John Deere see a bright future of deploying artificial intelligence, whether that's be sense and act or on the autonomy front, to help farmers around the world get their job done, again, in a way that makes them more profitable and more sustainable. We believe these technologies will have a future where we can have both of those things together.
And Jelly, we haven't really had a chance to talk much about what you're doing today in terms of satellite-based scouting. So maybe you can tell us a little bit about what Interplant's doing today, but also how you see that evolving over the next kind of 5, 10, and 15 years.
I was thinking, since we have an intimate group, maybe I'll philosophize a little bit. So if you think about Blue River Technologies, and we think about this transition because our signals are going to be read from satellites, but also from the equipment. It's kind of amazing how we went in the last century from a lot of small-scale agriculture that wasn't very productive and wasn't able to feed our population to then massive scale. Like massive scale, where one piece of equipment can cover, God knows, I don't know if it's hundreds or thousands of acres, but it's just a remarkable amount of efficiency. And then now, as we've done that, we're able to free up a lot of labor. So we went from about 40% of population farming in 1900 to 1.9% now. So that's the reason that everyone else can do some other things, because we don't have to feed the world all the time. But now we're getting to the next level of transition where we're going to still have this efficiency and we still have the equipment and we still don't need a lot of labor, but we have the ability to plant at the farm, at the individual plant level. And that's going to be kind of, in my mind, how we close the loop of having a system that works at scale, but is able to treat and understand every individual plant. And to that extent, it's all the technologies together, whether it's the plants communicating, the satellites to give us a scalable solution, the equipment that can then go out to the field, products that are optimized for early action and resolving problems in the beginning, and then the ability to apply them on the individual plant level. All this is like 10 years out, maybe 15, but I think it's 10. So it's kind of amazing that we can do all those things and not sacrifice any efficiency, be a lot more sustainable, and do it with the same, if not less, people.
And for me, it comes down to not only being able to be plant-specific in terms of applications, but to think with a systems biology perspective about how those plants are embedded into the microbiome and the wider ecosystem. And so the work that we do tries to take a lot of the kind of reductionist science that has taken place over the last 20 years in agriculture and move towards more of a systems biology approach. And how can we combine judicious use in the technologies that you develop, judicious use of chemistries, with really intelligent use of novel biologicals to support the whole spectrum of agronomic value, from soil health through to yield and everything in between.
And I would just add to that as we move from that reductionistic, I like that word.
I knew I'd get you on that.
I was going to call it one size fits all, but that also works. To biological solutions, they're a lot more diverse. So the idea is, can we then find a way to understand the diversity that we have in our fields, which is an extreme amount of variability, and then figure out where it works, where it doesn't work, how it works. I think that will unlock so many new solutions, as long as it's easy for the farmers to implement, right? Because the reason they chose those chemistries is because it was easy. Like, you put them, it works. So if you're going to transition to something else, you need to transition to something that is easy, but it can work a lot better. It's better for the soil, right? It's holistically bringing in the entire system and the soils as well.
Yeah, I totally agree. And I mean, Zach, from your perspective, how do you see technologies evolving? You're a man who looks at a lot of technologies across this space. Like, how do you see these things evolving?
Yeah, I mean, at a high level, it's undeniable that software and internet have been the major drivers of change in the world the last several decades. We have ubiquitous connectivity. We've had near real-time access to information, ability to process analysis information and workflows at almost zero marginal cost, and so they will continue to help push the world forward and help us to manage more sustainably the physical assets that we already have. The new frontiers, to say, are really in like the hard sciences. So the things that are going to change the nature of those physical assets that we have around us every day. I think software and data science will be instrumental in making the innovation cycle more efficient, to cycle faster, and to really improve the efficiency of research and development spend in those hard science areas. I mean, some of the areas that GIC is focused on more broadly, maybe not fully specific to ag, but to the broader ecosystem is obviously electric vehicles, electricity grids, wind, solar, and hydrogen. However, one of the areas I've been most excited about and been focused on most recently is that of just simply biology. It's amazing how efficient biology is. It self-replicates, it self-assembles, it puts atoms in the exact positions they need to be in. They are incredible to Shelley's point about sensing and responding to their environments. And so to perhaps like bring that framework to life, we can use Shelley's business at Interplan as an example to do that. And so, what her and her team have done is really use the unique trick in biology that allows a plant to generate a signal whenever it's under stress, whether that's nutrient stress, fungal and insect pressure, or drought stress. And what's unique about that there's a uniqueness to that technical signal in 4 ways. One, it's highly specific to the plant. It is incredibly important to the health of that plant. It's easily detectable, and it actually manifests itself days and weeks ahead of the visual signal that we traditionally get from that plant. And so as with any technical innovator, any entrepreneur, the real question is twofold. One, what does that really mean for the world? How much value does that create for a customer, for an end market? And then lastly, can you deliver that technology in an attractive business model? And so again, using her business as an example, why is this important? Like, why should we care, right? So getting that specific signal allows us to have an incredibly tailored response, an individual plant response. You no longer have to go treat an entire field with resource. You can do so only to the specific plants that need it and the amount that they need it. And so that's greater resource efficiency, that's lower cost, that's a more sustainable agronomic practice. In addition, getting that signal earlier allows for early intervention. Often with early intervention, you need less resource to kind of course correct the health cycle of that plant. In addition, the tool set that we have for early intervention is often broader. So there perhaps might be compounds out there that are more environmentally friendly, that are perfectly great at early intervention, but don't work for late stage intervention, which is where we often play today. And so when you roll all of that up, you have a healthier plant throughout the entire cycle. It leads to higher output, higher yields. You have more efficient input resource, which lowers your costs. And all of it adds up to a far more sustainable ecosystem. And so second question, how does that work from an attractive business model perspective? Well, the insight that her and little biological trick that her team has developed, they'll retain value for that. That technology needs to get into the seed, and so the companies that produce the seeds will receive their fair share of the value for granting that access. The infrastructure providers that do the sensing and go out and actually touch the plants will receive fair value for their services. The farmers will be given the opportunity to buy a product that hopefully raises revenues, raises output while lowering costs, and all of us win from the fact that agronomic system is far more sustainable.
I feel like, Shelley, I should give you a chance to also talk about your business, because Zach's just done a great job. Is there anything you want to add to that?
I honestly, we've been talking for a while. I think Zach gets it. I guess just the one thing that really aligns with me is just the ability to build a sustainable business first. I know that sounds like a cliche, but the reality is just, what's the understanding, what's the business model, what's the actual roadmap for 5 years ahead, where are the gaps, make sure there are no gaps. At the end of the day, if you want to have a technology that's implemented on hundreds of millions of acres and can actually provide the impact at that scale, it only will work if the economics work for every single person in the supply chain, from the farmers to the John Deeres, to the input providers, and so on. So I that's the framework at least, but he outlined it well.
And when we
What
think,
do you think about that?
when we think about the digitization of agriculture, what you are doing is obviously a huge step forward in terms of the plant being able to communicate and become a digital signal much earlier than it would be before. But like, where do we go from here? How do we think about on farm the potential to be able to grow the level of digitization and control and understanding?
The system, you mean?
It's a massive question.
I'm trying to think of
And maybe Ben.
Maybe from Ben, yeah.
Yeah, Ben, what's your view?
Yeah, I think the thing that I get excited about, kind of, if you take all this to its logical endpoint, is if you have a lot more genetics, and seed types available to farmers. If you have a lot more inputs, biologicals, what have you, to treat pressure or get the outcomes you want, then farmers can, to a certain extent, choose what they want to accomplish. Do I want to maximize profit or maximize output for food production, or do I want to maximize resilience because of climate volatility, minimize any downside risk? There's all kinds of things that, at least farmers I've met, they all have a slightly different optimization that they'd like to have in their business. And I think if we have all these new inputs and equipment that can help apply them, manipulate them, make every seed planted perfectly, make every input applied perfectly just where it's needed based on what it's sensing in the field, that combination of things, I think, is going to just unlock all this ingenuity that farmers around the world have in coming up with the thing that makes the most sense for their business, for their surrounding community needs, or their business needs, and kind of gets some pretty exciting outcomes. So I'm, despite some pressures that we see in agriculture, whether it be from climate or growing population, whatever, I think actually the resilience that all of these tools will provide is pretty exciting.
Can I ask if you can turn the volume up? Sorry. We're just having trouble hearing Ben a little bit there. Thank you. Shelley, the COVID pandemic gave us a pretty stark lesson in how agricultural resiliency reaches beyond the farm. Do these new data-centric technologies offer benefits beyond the farm?
Actually, we can just talk about fungus. No, I'm kidding, but I just wrote a piece. It's coming out in a few days, and it really is about this concept of resiliency. And COVID was a great wake-up call of, well, something can go really poorly, and we're not very, we reacted really fast, but we're very vulnerable to things like this, to pandemics. Think about just the evolution of diseases and pests in fields. So the UN published a report last year that 40% of our crops globally are lost to diseases and pests. And I remember when I started pitching InnerPlant, which was 4 years ago or so, there was a previous report. It was 25% back then. It got way worse in 10 years. The reality is that with climate change, our system is constantly evolving, and we're not very adaptable to it. There's no new products in the market. The EPA rules in the US are really tough, and basically it's impossible to launch a new product. So all of the pesticides that we have are 100 years old. I'm not exaggerating. And no one talks about it, and no one cares about it because fungus is not interesting. So there's almost no research on it. There's no funding on it. In climate, the only thing that people talk about in ag is nitrogen, and nitrogen is important. But the reality is, we just are not investing any resources in understanding diseases and pests. And when it happens, we're going to be very underprepared, because you don't want to start doing basic research when you actually have a problem. It takes 10 to 15 years to do basic research.
So Shelley and I come at fungi from a very different,
you come from the beneficial
angles.
side.
So at my business, we apply beneficial fungi to the seed to support carbon increase and stabilization. Shelley manages pathogenic fungi very, very effectively in terms of being able to signal earlier with the plant when we need to address those challenges. And I think this is a kind of a fundamental juxtaposition that we end in, which is where we can find a path towards ensuring microbial biodiversity, supporting plant health, and supporting soil health, but also being able to make sure we manage those pathogens really effectively, which are currently prolific in the soils because of the fact that we've lost a lot of the beneficial organisms. When you look at the landscape of biological technologies coming online, do you see opportunities to kind of technologies coming through that help to manage that juxtaposition?
Juxtaposition between
The
the
need
good and the
for
bad, or yeah. I mean, I think it back to a prior point I made on just like how incredible biology is, right? So we need solutions to manage the tough and harsh portions of biology, and then there's tremendous ways to harness its benefits in a proactive manner that are really, really truly benefit us. And so it's really just an engineering problem. And I think there's a lot of amazing ideas out there, and I think they're just, they're early, they need to be developed. And I think the biggest one is just the world needs to become aware of them and realize, that there's a large opportunity set of really great tools at our fingertips that we have yet to like fully implement and fully utilize.
And Ben, over to you. I mean, how do you, as John Deere and See and Spray, obviously you're working very hard to provide a more targeted view. How do you see that technology evolve, and how can we work to ensure that we maintain and maximize soil health, as well as being able to make sure that we maximize the use of the most effective technologies we have to increase food yields?
I think one of the things that See and Spray can enable is more innovation around the pesticides or other things, or even fertilizers that we can apply, because we're no longer, with See and Spray, we're no longer broadcasting across the entire field, but rather only selectively putting things where we want. It changes the whole economic return calculation for a farmer. No longer do they have to calculate this is going to cost $50 a hectare. It would be more about, hey, this could cost, I would apply a fraction to the hectare. And so all of a sudden I can use a lot more expensive inputs and bring, again, more diversity of inputs in, maybe even have some diversity of practices like low-till or no-till that drive a lot of soil health. And I think that putting that together can, again, manage the bad with different, maybe even more expensive inputs that become economical to deploy only where the problem is, paired with some of the other soil health initiatives that were discussed.
There is theoretically a Q&A component to this talk. Now, I know some of you have kind of dripped in as we've been talking, but are there any questions from the floor? Is there anything anyone wants to ask about agricultural resiliency, about how we develop new technologies in agriculture? Please.
So I've heard a lot about the context that's been applied in the US, right? People with large land holdings, with capital to access all the technology. So I'm wondering, on the other side of the globe, where like we got smallholder farmers, we got farmers who doesn't have capital to invest, what kind of technology that we can think about when we want to improve their life and, spearhead this kind of thing?
It's a brilliant question. Ben, I might start with you on that one as the large enterprise in the room.
Sure. I think we work hard to figure out how to, like I mentioned earlier, right size the solutions, right size the technology, right size the products to the local needs. And I know that there's just some initial work in India right now, I believe, that John Deere is doing, and getting more of the equipment used there connected so that farmers can get data from their equipment up into the cloud, and then use, have more digital management, whether that be work planning or managing fuel, managing assets, even making prescriptions. And so I think that there's a lot of, things, technologies that can be thoughtfully deployed in a right-sized way to different situations.
And Shelley, how do you see your technology scaling to smallholders and other regions?
Yeah, I was actually going to say, so it's a great question, and there's not a lot of technologies that do spread that way, but some technologies get adopted. Everything gets adopted by the large-scale farmers, right? Because they have capital, they're incredibly efficient, they're constantly looking for solutions that are going to improve their ROI. But some technologies then carry through to basically any farmer within at least a region. So genetically engineered seeds were just that. They started with the larger producers, and then within 8 years, there was 60%, or actually within 6 years, there was 80% adoption. And nowadays in the US, you could be farming 100 acres, 50 acres, you'll have those seeds. There's various technologies like that, but I don't think they'll ever start with the smaller farmers because the small farmers just don't have the capital to invest, and then you can't really make the business scale. But if the unit economics are there, eventually there's really no reason that it's not going to be accessible for everyone.
And I mean, fundamentally, for me, it comes down to how we can use the larger farmers to be able to build data models and build operational efficiencies that allow us to deploy these technologies at scale globally. And there are great opportunities within developed markets for us to be able to do that really effectively, and then be able to make sure that we can deliver these at a cost point that works. And for me, fundamentally, a key part of that is how do we channel climate finance to some of those who are being hardest hit? And the environmental impact of agriculture, current environmental impacts of agriculture, but also the enormous opportunity that agriculture has to play a crucial role in being a solution when it comes to climate change, means we need to mobilize farmers, and we need to mobilize farmers everywhere. And we've got to do so in a way that makes economic sense, it provides a positive economic return to those farming businesses rather than being a cost. There's another question there.
Thank you. My name is Susan Payne. I'm the co-founder of a business called Sustainable Planet, and we grow plant protein on non-arable land using 20 times less water than soya. And just separating the two issues out, one of them, your point about home farms, lifting the boats around them or lifting the smallholders. I own home farms in Africa. There's a huge impact. That's a separate issue, and I really think it's an important one to understand how massive the home farm is to the whole ecosystem around it. But on this gentleman's question about technology and smallholders, I think we have to sort of come back to the basics. And I understand your point, and I completely agree with the fact that we have to keep it simple, really simple for smallholders to participate. But to get to my point, we have technology at Sustainable Planet, and what we do is we have smallholders grow for us. So they grow volumes of plant protein for us. We are the offtake, and we have the technology to transform this plant protein into a colorless, odorless powder. And the tech is upstream, but we employ and pay far more income to those growing for us downstream. So at the coal face, we employ hundreds, potentially thousands of smallholders and improve their economic positions, and they get bank accounts, they can get training, they improve their nutritional value in a company that addresses all 17 SDGs. But the technology is held at a different level where we can produce this fantastic powder that goes into all sorts of different food products, from Millie Meal in schools to protein bars, protein shakes, protein pasta, etc., but very sustainably. So I think we have to kind of relook at how we engage smallholders. It's not technology at the smallholder level, it's how we use it to engage and to assist holders to have a better life. Thank you.
Thank you very much. I mean, Zach, obviously in Singapore, you're sourcing from a lot around the region, a lot of smallholders you work with. Do you want to comment on the remark there?
I don't know if I have a lot to add. I mean, you made some fantastic points, right? I think there are obviously some technologies that need to be scaled, right? So you start out in one part of the market and you gain traction, you gain learnings, and you can drive the cost structure down over time. That opens up more market you can go after. There's other technologies that are incredibly efficient from the get-go that can work everywhere, right? And so I think it's just a question on the type of technology, where it can be applied, what position of the market it can enter into and when. And I think that's a little bit bespoke and specific to every single business, every single new innovation.
Do you have any other comments or questions from the floor? So, quarter two? I mean, from our perspective, I think. We wrap it? All right. I'll give it one more opportunity for anyone who wants to ask anything about agriculture, climate change, and how agriculture can be a part of the solution to climate change. But if not, we'll wrap it up. Yeah, sure.
I'll make this very brief. It's not about Sustainable Planet. It's about the fact that I see so much technology on the ground in Africa that is so innovative and so impactful, and it requires literally between $1 and $5 million of support for many of these companies that are going to be game changers, that are really critical. So while we all sit and discuss 20 billion, 20 trillion, these enormous numbers, we have to actually get down to basics, to the level that makes a difference, to the level where we all can actually benefit, and really drill into where we can unleash that technology. And I really think that it's an opportunity here to do that. It's not just about what we're doing, it's about what many of our colleagues and co-companies that I come across countless times across the continent are doing. And I genuinely think that if we do not take advantage of these opportunities to fund these companies that are making huge impact on the ground to climate change, I mean, our company, this plant, is climate positive. It actually basically produces huge amounts of oxygen, absorbs carbon emissions. There are many other technologies that do positive things for the climate. We have to invest in those. Thanks.
I think it's a great point, and look, it's a really optimistic one. I think as we look at the role of agriculture in climate change over the last decades, it has been a challenge in terms of the emissions that we produce. But over the coming decades, what we will see is that it's a really crucial solution. And our ability to be able to manage soil, which is the largest terrestrial carbon sink, and be able to have 1 billion people who work every day at the interface of soil and atmosphere, deliver environmental outcomes, deliver environmental impact in a positive sense, is absolutely crucial in terms of how we buy ourselves some time as we bring other climate technologies on board. It's one opportunity we have. An enormous part of that is how we ensure that we maximize the use of nutrients and synthetics to be able to produce the food that we require as a global population. And in addition to that, be able to play a really crucial role in carbon sequestration and storage in soil. Thank you all very much for coming in. If you would like to talk to the panelists here, Shelley, Zach, Ben, thank you very much for joining us. And yeah, on to the next thing.
Thank you.